So now the next idea to explore here is complex fractions. So for starters, if we have a fraction over a fraction, the idea is to keep change flip. So basically we change to a multiplication problem and we flip the second fraction upside down. Okay, and then we disregard this. So the x's in this case can cancel, right? Remember cross-canceling lesson. 2 times 2 equals 4. So that's our result. Now, one step beyond that, if we had, for example, 1 over a fraction, that just means we have to flip the fraction upside down. Now, on the other hand, if we had, let's say, 4 over the fraction, then the best thing to do there is to take that 4 and turn it into 4 over 1. Then we've reduced it to a problem we already know how to solve, because we solved this by keep change flip. So we change to multiplication, we flip this over, okay, and then we can solve by cross canceling. So the 4 becomes 2 times 2, these 2's can cancel, and we end up with 6. Okay. And finally, the third possibility is that we might have 2/3 over 4, and in this case we solve it by a similar way. Basically, if one of them doesn't look like a fraction, it looks like a number, we can turn it into a fraction to make things a little bit easier. We can always resort back to this keep change flip idea. So we end up with multiplying by the reciprocal. Whoops. And then, yeah, so here we can cancel this 4, make it 2 times 2, and then the 2's can cross cancel here. And then we'd end up with 1/6. Okay, it's a good habit to do it that way. Even with small numbers, you can just do tops and bottoms and then reduce. But it's a good habit to always check for cross canceling. Okay. Right, so now we're going to put it all together. We're going to use the cross multiply method, okay, to combine this into one fraction, and then we'll use the keep change flip. Right, so here we go. 1 times x is x. Then we put a minus. 1 times y is y. Divide by the product of the denominators, xy. And we then rewrite the numerator. Okay. Now it's time to keep change flip. So we multiply by the flipped version of the bottom. Okay. And here we can cross cancel these y's. And we can cross cancel these x minus y's, leaving just x as the result. So that's pretty neat. This did not look like it would be having such a simple answer, did it? Well, that's the benefit of these methods, is that it will tell you whether the answer is simple or not. Okay, so this one I'm just going to rewrite because well, it's kind of a pet peeve where they put the m in the middle. It doesn't belong in the middle, it belongs on the top. Anyway, we can put a 1 underneath, right? And then we can cross multiply method this, or we can use the fact that one is a multiple of the other, which is a better idea. So I'll put m here and here. So we'll end up with an m squared on the top. Okay. And an m common denominator on the bottom. So m squared minus 1 over m will be the result of that. Then we can keep change flip. Okay. Now these m's can cross cancel. This can be factored into m plus 1, m minus 1. And then the 1 minus m can cancel with the m minus 1, but we need to write a minus sign. So the final answer will be this. Okay? So you see, these are quite a joy to solve when you know the right way to do it. Okay. We'll do one more. So this time we'll do a cross multiply here. We'll get b. Then we put the symbol in the middle, minus a times 1 is a over ab. Okay. And so then we do a keep change flip. We multiply by ab over b minus a. This ab can cancel with this ab. We end up with 1 over b minus a. All right. So I think we get the idea. So we can move forward. Here are some more examples if you wanted to practice. And here are some more examples again. Okay, so we finally made it to the last section of our fractions. And for this section, we're going to be solving equations in a similar fashion to what we've seen before. So for starters, if we have the same denominator, then we are able to combine these in the way that we've seen before. But what would be even better is if we had the same denominator on the left side and right side. And we could achieve that by multiplying 5 and 5 right here. So then we'd end up with 5 over 5n equals 1 over 5n minus n minus 1 over 5n. And the benefit of having this situation is that once we get all the denominators to be the same, then we can completely disregard the denominators from that point on. So that is a very ideal situation. Gets rid of all the denominators. Okay. So now it simplifies down to a problem that we already know how to solve. To keep in mind that you need to put a parentheses on this guy. So anyway, we have 5 equals 1, and then the minus sign distributes, minus n plus 1. 1 and 1 makes a 2. And then we could subtract that 2 to get 3 is negative n, and we take the negative of the entire equation to get n equals negative 3. So we're switching every single sign. Okay, so on the bottom number 4 here, we can do a similar idea. So we have to see, well, how can we get them all to be the same? The answer is we can multiply by n right here. And once we accomplish that, we no longer need to write the denominator. Once we get them all to match, that's the idea. Now, we add 1 here, get 5 equals 5n, divide by 5, and we get n equals 1. Okay? So I think you can start to see the pattern. So we have to see what's missing here. Now in this case, I'm missing an n right here because I have a 2n squared. Whereas here I've only got a 2n, so I'm missing the extra n. And here I'm missing the 2 that goes in front of the n squared. Okay. Right. So now the bottoms are all the same. So then I can just use the tops to solve the rest of the question. I distribute this 2. That gives me 2n minus 4. Then I subtract 2n. And that gives me 3n. Subtract 1. Get minus 5. And divide by 3. So I end up with n is negative 5/3. Right, so you can see these are pretty useful techniques. They're definitely coming in handy. Now, let's see what we have here. This looks pretty complicated, right? But it's not as bad as you might think. So we can apply our methods that we've learned, starting with the trinomial factoring. So we move this minus sign down. This indicates that both signs are the same. So this ought to be a minus as well. The numbers are 5 and 2. They combined product at 10, and the sum is 7. And of course this is exactly the same, so I can do just the same thing. And you notice what's missing. So in this middle piece, middle term here, I'm missing a b minus 5 as a factor for my denominator. So that needs to be included on the bottom and the top. Okay. Now that all the bottoms are the same, the great benefit here is we can then disregard the denominators, which is a great feature. Okay. Whenever we have 1 times something, we just have that thing. Okay. So then 1 with minus 5 is negative 4. And then we can add 4 to both sides. Okay. So moving right along, we can here factor out a p, and we'll have p minus 5. And you notice what's missing, right? So this is the full common denominator. So what's missing here is just a p on top and bottom, and then here a p minus 5 on top and bottom. Okay. So now that we've got the denominators all to match, we can just cancel them. And we have here, if we distribute, 6p minus 30 equals 1p. Then this minus sign has to distribute to both pieces. Whoops. So then we notice that these will cancel. We add 30. And this is not divisible, but at least we can reduce it to 13 halves. Is that right? 13 thirds? Okay.